Hello, everyone, and welcome to the AQUALIS Sustainable Water Compliance Summit session, How to Solve Wastewater Collection Challenges with AI and Data Science, a case study. I am Bob Crossan. I'm the editorial director for Endeavor Business Media's Water Group. To begin, let me explain how you can participate in today's event. First of all, if you have any technical difficulties during the event or during this cast, please put your question into the questions window and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we welcome your questions during the event today. We will answer as many questions as possible during the Q&A session at the end, which will follow this presentation. But please feel free to send in questions at any time during the presentation. To do so, simply type your questions into the question window on the side of your screen and hit the submit button. Also, please be aware that today's event is being recorded and you will be notified via email when an archive is available. That goes for all the sessions that you're attending today and any that you were unable to attend. At the conclusion of the webinar, you will receive an email with a link to download a certificate which can be used to submit for credit with Stormwater University or to serve as one professional development hour for attending today's webinar. Certificates will be sent to attendees who viewed this session for a minimum of 50 minutes. For those viewing the session on demand, you will need to complete and pass a short quiz at the end of the session to receive your certificate link. Now, let me introduce today's speakers. First, we have Jayesh Srivastava. He's head of data science, GHD Digital. Jayesh stands at the intersection of data science and water management with 2 decades of pioneering AI and machine learning applications in environmental challenges. Notable work of his includes involving creating an advanced analytics framework for managing inflow and infiltration, blending scalable data processing with machine learning to enhance sewer data accuracy and efficiency, and leading to significant compliance cost reductions. He also spearheaded the development of a risk modeling framework for sewer networks, employing Python and data analytics tools to generate dynamic, interactive risk visualizations. His expertise exemplifies the impactful merger of data science with water sector needs, showcasing significant strides toward urban water sustainability and infrastructure resilience. And his work serves as a compelling example of how data analytics can revolutionize water management practices. We also have Bhavin. He is a senior data scientist for Water, GHD Digital. Bhavin has more than 10 years of diverse experience of operations, management, and design of municipal and industrial water and wastewater projects. He leads the development of advanced analytics offerings for all of GHD North America's water service business units. These include analytical and statistical methodologies and software tools, whose collective goal is to support our technical teams and subject matter experts in all stages of a project. Being a skilled ideator, Bhavin is driven by an intrinsic curiosity about client challenges, which he combines with a deep knowledge of what's possible using the latest artificial intelligence and machine learning technologies. He has delivered several database solutions to his clients, including smart asset management, hydraulic modeling, CIP, public health, equity, process engineering, water economics, and water resources. Now, with that and the lengthy biographies, I'd love to turn it over to Bhavin and to Jayesh. Thank you both for being here, and you may start your presentation.
Thank you, Bob, for introducing us. That was very detailed, and I'm really honored to present out here at this conference today, and appreciate this opportunity very much. So as Bob mentioned, my name is Bhavin. I lead the analytics for water. Analytics, I've got to say, I've been on the operations side, I've been on the utility side. I'm not on the chemistry side, but as Bob mentioned, and as you can see from the screen, from the title, it's all about the data analytics. And today we'll be sharing today through this conversation, through this presentation, we're going to go over the whole suite of what is possible using data analytics and other advanced approaches, including artificial intelligence, machine learning, and back it up with the actual case study that supports our experience. But to give you an overview of this knowledge share, we'll begin with the status of industry, the challenges that we currently face, the progress that we have made, and an example of case study, as I mentioned, using an approach that we pioneered in-house. Now I know many of you already know this. We have one of the longest linear asset on the planet when it comes to wastewater infrastructure. For example, the total length of our storm sewers is about 15 times the distance to the moon, while the length of our sewer pipes equals 3 times the distance to the moon. So think about it. We could literally go to the moon, come back, and then go again, and still have some change left over for our sewer pipes. That's the distance that we have. That's the length. Now, when I got to know about that, I thought that was really impressive. But we, being a data scientist, I wanted to get further, deep inside the data and see how we were doing. Dipping further into the data, I found out that the average age of sanitary pipe is almost 45 years. And as most of you know, the expected lifespan is between 50 and 100 years. So our average sewer pipe, it's nearing its expected lifetime. This is a concern. And these numbers are 2021 numbers. And having been on the utility side and now on the data side, I have been exposed to this enough, but there's an increase in funding gap for several reasons, which has led to deferred action on our linear assets, which were already showing signs of some trouble. So much trouble that ASCE has given these valued and priced assets a score of D. Issues like urban flooding are not only common, but becoming more frequent. Climate change is also not helping us, given that flash floods have been the norm for many regions during the wet season. Now, I just pasted titles of 3 articles, and these are quite recent, but I'm sure if you just Google on Google News, you will get plenty of these articles. Climate, as I mentioned about climate change, leading to much flash floods, especially during the wet season. And to add to this, there's a looming crisis of retirement in the coming decade. So all in all, we have an aging asset problem compounded by deferred investment, and then comes climate change and increasing retirement. There are plenty, I'm sure there are much more experienced utility folks out here that can narrate more, but I see this as an opportunity, and as an opportunity for digital technologies to address some of these issues. For example, by using connected infrastructure, digital technologies, we can get readings, and I'm sure many of us already do that, for water quality, the flow readings, all remotely. And by using the data analytics, and in some cases, AI/ML, that's artificial intelligence, machine learning, we can perform complex analytics that can not only identify the issues, but also predict the issues. And it goes from reactive to predictive and to even prescriptive. We can take all these modern technologies, digital technologies can help us get there, wherein we can say, okay, if you do this, this may happen. And this all depends on historical data, but our water domain is so rich in data. Now, predictive technologies that, like I mentioned, that includes data analytics, AI/ML, those are all different. They can assist with predictive maintenance issues. They can assist with your CIP planning. They can assist with your prioritization of projects and keeping the continuity of knowledge in-house, just to mention a few. So that's why I strongly believe that advanced analytics and digital technologies can answer some of these issues that we are facing these days. Now, I'm going to request Jayesh to go over the various areas in which utilities are utilizing digital technologies and some of our experience. Over to you, Jayesh.
Oh, thanks, Bhavin. And so, like today, I'm very excited to share our experience with using digital technologies, especially in the field of data science and artificial intelligence in our sector, utilities. But before we go there, I think it's good for us to see what our peers are doing. And so, in this slide, it shows you a recent survey conducted where a lot of senior leaders participated, and we asked them questions like how they are using the digital technologies in their area. You can see like most of them are using in process automation, operation analytics, and predictive and preventive maintenance, as Bhavin said. So in water utilities, the process automation and enhanced by data science mean more than just an efficiency for us. It actually talks about the sustainability. The automated system or process which use AI and machine learning, they can adjust in real time by utilizing the data that they see. And if the data changes, they can adjust themselves for the water quality or the demand, ensuring not only about the cost saving, but also environmental protections. 45% of the responder, they talked about the operational efficiency or operational analytics. They are basically using the data science or big data in streamlining their operation. This could mean many things, but more importantly for us, it's like better management of water flow and process across the network, which help us in reducing the leaks and burst, which which are costly and disruptive for our community. The 40% of the responder did talk about the predictive or preventive maintenance. By using that, the equipment failure can be stopped. We can avoid expensive emergency repairs and reduce water service interruption to our community. And that is a game changer for our sector. However, if you see across all the areas, only 12% of the folks are talking about big data and an AI ML driven solution in asset management or in asset lifecycle management, which shows that there is an untapped potential, like data can be used much more efficiently in that area. The data-driven strategy can extend the lifespan of our critical infrastructure from pipes to the treatment facilities that ensure we get most out of our investment, and it helps us to extend the asset life that we have. However, adopting these new technologies is always come with some challenges, but there is a consensus across the board that the implementing these technologies can reduce our operational cost by 25%, and it can increase the performance and in the range of 20 to 40% in safety, reliability, customer satisfaction, or regulatory compliance. And all of these things are very important for our sector. As I said in the prior slide, normally when we try to use new technologies, it always comes from it. We have to always, face some challenges, and utilities are also in that space. So we are trying to make the changes, but naturally there are a lot of things that we have to handle. What we have seen across all the utilities, normally when it comes to utilizing the digital transformation or data-driven applications, we need to have three basic things at our disposal. So one thing is, it is all about data. So we need to have a process where we can collect the data in a meaningful way. we can manage the data and organize it so that it can be used for downstream analytics. A lot of our assets are geographically distributed, so it's very important that we use all this data point and visualize on the map and see like how those projects are impacting the close by communities. Finally, all this data that we are organizing or processing, it does require a lot of compute power, but a lot of artificial intelligence and machine learning algorithms can be utilized on them, and we create all the insights. All right, so we need to have all that platform or underlying tools and technology in place to process that large chunk of the data. We bundle all those things together under digital intelligence. So under that umbrella, we talk about collecting the data, managing the data, and processing the data. But once you generate all those insights, right, if you cannot able to share to the user base or the people who are acting on those insights in a meaningful way, then it is not going to increase the adoption of those data science tools. So creating a digital experience is absolutely necessary. Otherwise, you will be generating lot of capabilities which are not going to used in day-to-day business operation. In order to do so, it's important, as Bhavin mentioned before, also that we need to have a connected infrastructure. A lot of data is being captured through sensor or on the ground. So I think the connected infrastructure is needed. Since the data is captured from the equipments and everything is virtual, it's important that we need to have a very robust cybersecurity policies in place, or the infrastructure that basically supports the transformation of data, transferring the data from one place to another. After COVID, lot of time there is a hybrid work culture, so a lot of people are remote logging in. So the cybersecurity becomes very important. And then we are talking about the assets that we need to manage and how the data that is being collected from those assets are utilized in asset lifecycle management. In order to do that, it's important for us to have like a digital version of that assets, and that triggers all the work stream around digital twins. Right? And when we are trying to understand the process, it's important for us to also engage with the business stakeholder and community people. So there is a whole process around how we collect those information and feedback and feed back into our process engineering. Okay. And we call that we call all those activity and put under the digital experience. Not every utility or every agency will have everything, but basically they have a proactive way of creating these things, and we have to start from somewhere. So whatever they have, we are utilizing that and building on top of it. And that cannot happen if they don't have a group of people or few folks who are basically focusing on innovation. And as innovation is the key in leading these changes. So it is expected, like, there will be someone in the agency who is promoting this culture change or change management and focusing on how to use the innovation in that process. So if we have these three things, you will see a lot more success in digital transformation or adoption of data science driven tools. Some agencies are a lot mature, some are still evolving, but we see this across the board. Okay, so previous slide was more about like overall what need to be there in order to see the success from data science tools. But let's talk very specific about the water utilities, the problem that we are seeing. But before we go in deep in the water utility, let me share my personal journey as as I came from the banking and financial domain, where we are basically using data science to generate a profit for our company, which traditionally means like taking a large sum of data, identifying trends and patterns so that we can differentiate our product and services in a marketplace, which gives us a leverage in price setting up the price so that we can create a unique value and we can charge the price that we think is reasonable for us to get for that value creation. But it's all about generating more money in less time by optimizing the resources that we have on our disposal. But when I joined GHD and focused in the utilities, I realized that we have really important or complex problem to solve, which is very valuable for our community and in person for me too, like because we are using those services on day-to-day basis. So it's not about like generating the profit. It's more about providing the services to everyone and that gets fair and consistent access to the water services, basically. And that's the motivation or driving factor why I come to the work on every day. Yeah. So we have taken a lot of data and tried to solve very different problems, but it is all about how to generate more value from the data. Here, we are still using the same technique, but we are focusing on how to provide better services to the community that we are serving. So let's focus on the problems that basically we are solving in water utility. Okay. So everything starts in my mind is from the treatment plant. Like treatment plant is something which is key in the water utilities, where we process large volume of the data. And data science is changing dramatically a lot of processes in water treatment plant that operates like their efficiency is critical for us, and their sustainability is also important. We use a lot of real-time data from the treatment plant and measure the nutrients like nitrogen and phosphorus and try to predict their concentration with great precision. This basically helps us in keeping the ecological balance and complying with the strict environmental standards. Moreover, by applying the machine learning models and predictive models, the treatment facility actually can adapt to changes in the water inflow and contamination level quickly. This enables plants to use the chemical in an optimal way. It also helps us to reduce the energy consumptions and resource allocation, which in turn basically reduce the waste and operational cost. So a lot of things goes into the treatment plant. But then the water that is being treated is distributed back to the community through the linear infrastructure. As Bhavin talked, we have a large linear infrastructure to manage. And the quality of linear infrastructure is directly related to the public health. As you know, like there is a huge push on the lead service line replacement, which is playing a key role. Like right now, a lot of data science is being used in terms of creating that lead inventory. We need to know like where is a higher chances of finding the lead pipes. And in order to do that, like people are using a lot of public sources data, tap card information, and trying to predict which houses will have lead. And data science is enabling our client and utilities to create a lead inventory in short period of time, because they're using the machine learning algorithms and predicting the houses where they can have more lead. The another area there where we are seeing that data science is currently used, heavily utilized, is in condition assessment. In sewer pipe, they collect a lot of CCTV footage, and someone has to analyze those footage. The machine learning algorithm is making it a lot more like easy for people to narrow down the area where the experts need to look into, and it does free up a lot of lot of time from the expert, and they can focus on the particular section of the pipe that need to be taken care of. Then I think when we are delivering all these services, it's important for us to pay attention to the disadvantaged community. Like a lot of our risk models that we build, they take environmental justice factor and assign the risk accordingly. That's how we prioritize the risk. In that, we also reach out to the public and get a lot of information and from their perspective, so that we can prioritize the project accordingly. And it all feeds into the master plan or capital improvement plan. So a lot of time we have to predict based on the certain budget that we have, which projects need to be executed more compared to others. So prioritization of a project in asset management is heavily data driven, but the environmental justice factor affects that too. Bhavin, do you have anything to share in this? I know because you're working a lot in equity analytics and capital plan. Bhavin?
Water side of things. So thank you, Jayesh. I was probably muted. So Jayesh talked about lead service line, which talks more on the water side of things. And on the wastewater, similarly, there's been issue of laterals being that need work on them. So data science can be deployed to identify those laterals that are of concern. Equity analytics, I understand it's of not only as a human and as a person, I'm really interested, and that's one of my driving factors of keeping going, but it's also because it's a source of federal funds. Based on my research, it's a significant amount of funds from the federal agencies have been reserved for disadvantaged communities. So doing this not only helps build a trust with customers, but also it's good for utilities to get funds from federal agencies. And all this feeds into master planning, which is really important because we always strive to get everyone on the board, all the stakeholders, we get their inputs whenever we have to on how to maintain the system, how to protect public health, and do it economically, as well as build resilience against several factors, including climate change. So we have seen use of analytics being used in all of these areas. Now, talking about the case study and how we have seen use of data analytics on capital improvement program, the idea is to use data analytics, and we have been, so the client is City of Fort Myers, based in Florida. It's located in Lee County in Florida with a land area of slightly less than 50 square miles. The population keeps on increasing because as you are aware of the migration down south from a lot of northern states, and it keeps on growing. It's mentioned on their website, official website as well, talking about the wastewater system that they have in place. They have 2 advanced wastewater treatment facilities with a combined treatment capacity of 23 million gallons per day. There are 4 planned DIWs, and they have the sewer system is about 356 miles, supported by 201 lift stations. Talking about the challenges, and these are important because this is what we are striving to address. There have been numerous capacity issues because of growth. The SSOs, as many of you know, climate change impacts, definitely, aging infrastructure, and all of these creates hurdles in creating a positive impact, being more proactive, because there are a lot of issues, and how do we address them? So that's where we saw the need for digital technologies, specifically data analytics. Talking about our approach, what we adapted for this, we developed this system called the Decision Support System. And it wasn't just using data science, data analytics, like what you have been hearing about till now. We actually used the principles of IWM, Integrated Water Management. And why? Because we want to take into account the whole pipeline of the journey of water. And that is important. Data science does not function in vacuum. We need to be guided by domain experts like yourself. That's how we work. There's a domain expert, there's a client expert, because that's what guides us to make solutions that are that provide actionable insights. So that's the key. And talking about further in the next slide, it's, as I mentioned earlier, we work with number of other subject matter experts. I'm going to keep aside the digital piece and talk more on the water and the planning piece right on this particular slide, because that is of interest. And on the water side, we take into account all the modeling that is performed, both hydrology and hydraulic modeling. As I mentioned earlier, the IWM principles and condition assessment. That's also really important to help build the CIP DSS system that we have built. Now, all of this had to be supported by risk modeling. As Jayesh mentioned, there were a lot of rule governance and policies, and the fundamentals of the client. What is their approach to CIP? What is their approach to operation and maintenance? All of that had to be considered. So as you can imagine, there was a lot of data involved. So this was essentially a data-centric approach, wherein we connected different data sets that were basically silos till date, and we developed what we call an analytics database, when we brought all of the data together, performed a correlation, wanted to make sure that what one data set, let's say GIS says on one for one street, for one asset, that's the same thing that the hydraulic model says. So that one-on-one correlation was developed. And we used the asset management and capital planning framework, the EPA's, the standard EPA asset management framework was adapted for this, which eventually, now imagine you are integrating different data sets. Now, what happens now is people that had limited conversations, they are collaborating more efficiently. The GIS team is talking better with the modeling team, with the asset management team, because everyone is on the same page about a particular asset. I've recently seen when that is not present, it leads to a lot of problems, because when you try to speak the same language, that does not exist, that was not possible. So we, by doing this integration and correlation, we made collaboration more efficient, which eventually leads to improvement and optimization, because everyone spoke the different language earlier. Now we created the same language. They were able to converse with each other and share their problems. And if somebody shared the problem, the other person came up with a solution, because they were on the other side and they understood that issue and they had the data to address it. So it improved and optimized. And that's what we brought to the table with this DSS system. And it automatically, when people converse in the same language, there's more communication with the diversity of thought, it can significantly reduce your cost and risk. And as Jayesh mentioned in the earlier slides, there's tremendous potential to reduce cost in different aspects. Talking about our DSS system, what we have done is we have developed a web application. And this web application, it is more feature-rich than your traditional dashboard. Think about it. I'm going to give a really layman's example. Think about it that earlier you had those the TVs, the back old. I grew up with a black and white TV in 1980, early 1980s, and then we had color TV. They had better features. You could see the movement really better. And then we are recently upgraded to 4K, and now there is OLED TV, so better, more picture, better visualization. And that's the difference between a dashboard and a web app in a very layman's term. I'm sure many of you who are digitally savvy can come up with better definitions, but that's how I see it. Dashboards, they tend to focus on summarizing and presenting in a user-friendly way with some grasp of trends and patterns, but when it comes to web apps, they can help you perform real-time data updates and better geospatial analysis, better spatial querying. So it basically provides users to interact with spatial data in more complex ways, and that's what we did, and that's what is making this possible. All the different boxes out here are different modules that are based on the digital technologies like data analytics, AI, ML, and I'm talking about smart asset management, dynamic hydraulic modeling, adaptive planning, financial planning, and even resiliency. That box, that's our current under development. But the different in these modules, there are different sub-modules, and I'm going to demo some of these today. I'm talking about the risk modeling that Jayesh earlier talked about, but this would be more from an asset management perspective, scenario planning and adaptive planning, CIP optimization, and then under financial planning, I'll be showcasing some of the features on the financial projections. Now, all of these, I've talked a lot and from different buckets. So all of these, we are currently our DSS that is in process that we have developed. The idea is to apply it for water, wastewater, as well as stormwater, because I understand that the concepts are those three areas are different from each other, but for data analytics, and it's all about taking the trends and patterns, developing the predictive algorithms based on historical data. So from a data analytics perspective, that's the base, and that can be applied cross-section. Talking about the risk modeling, when I say risk modeling, it's about developing a dynamic risk modeling, wherein we are able to change the values, we are able to predict the values, all based on predictive analytics and machine learning. And as part of our effort, we are able to do this for City of Fort Myers, and we based our risk prediction on the projection year. Which year would you like to project it on? We use the EPA's asset management framework principles, and it was supported by a lot of domain and system knowledge, as I mentioned earlier. All of this visualization is on a dynamic map, and this was enabled for all of the risk metrics that you would commonly hear in asset management, like likelihood of failure, consequence of failure, and core risk. And we had prioritized all the projects based on different priority levels. Now, all of these can be adapted for different clients if they have a certain preference on how do they define priority, how do they define the risk metrics. So what we call the back end of this particular system, the actual brain of the DSS, it can be customized. The idea is to customize it for clients according to their needs and according to the business problem that we are solving. As well, now we also wanted to make this go further. The idea would be to have a multidimensional views of the CIP. So I understand, being on the utility side, there are different projects and different categories. So the idea was to enable the filtering of project according to the categories and make it more operator compatible. Not everyone has the same exposure to digital technologies. We understand that, but most of us use a smartphone. So we wanted to make the visualization and the operation of this DSS as simple as using a smartphone. So that was risk modeling. In the scenario management, we have developed a way by which we could take two different scenarios. On the picture, you can see that we have two different scenarios. One is for a certain year and the other one is for another year. And this is for a sewer network. So we had different metrics that we had calculated and so you could predict those metrics. You could predict those metrics for those two scenarios, and the metrics were for CIP as well as O&M, and both those windows, they are synced. So if you zoom on one side, let's say the left panel is for 2024 current, and you want to see, okay, what's on 2045, we could zoom in. If you zoom into 2024, the same level of zoom would happen for 2045. That would provide the optimal experience when you're doing such comparison studies. Talking about the CIP planning, I'm so used to Gantt charts because that's how I've grown up. So we enable this Gantt chart project style project visualization and prioritization. And we all know about the business case evaluation. We evaluate our business cases for each and every project. So we wanted to enable that on a really dynamic way. So what you see on the picture is, you see on the left panel in the screen, you see a Gantt chart with all the different projects that you can drill down according to the type and according to the risk metric, and they all have a cost associated, and all of that cost becomes annualized, and it shows up on the top bar where I'm pointing my screen. And I'll be showing a demo, so no need to worry to strain your eyes if it does not show up, but I wanted to give this brief overview before I run into the demo. And the idea was that we provide more customization and dynamic capability, so you can drag these boxes. Let's say we don't have a budget for that year for that particular project, and you drag this on the towards the next years wherever you want to place, and you can immediately see these numbers change. And I'll show a demo of that. So that is really important, especially when you're working on master plans, on your CIP plans, because things change. Some costs may increase on a current project, and you may need to change when you want to start on another project. And doing it on Excel is no fun. I've been there. So doing this on an advanced system like DSS is really the key.
Bhavin, I think we need to speed up. There is a very limited time so you can quickly go through the demo.
So I'll go over the demo. So I'm sharing my screen. This is a demo of our DSS system. We have all the cybersecurity in this because we want to make sure the client's data is protected. And as you can see, this is the sewer system, and I'm going to put it for 2024. This is the, and it says updating risk for 2024. The blue dots are the lift stations, as we discussed earlier. And the model says, okay, the current assets, they're in good place. And the idea is for us to provide all the different risk metrics, including the COF, POF, and the core risk. And we can say, okay, I just want to look at the moderate ones or the high ones, and moderate and high. So you can drill down and see which system, which asset has an issue. And then we, as I mentioned earlier, we also did prioritization according to the logic that was agreed on with the client. So we, let's say we want to just drill down to the priority that was not priority 1. So we, okay, that's priority 3, and here we go. It's on priority 3. So we can drill this down further. And we, as we started earlier on 2045, if we could also drill down to the 2045, and it would say, okay, now we have updated the model, and you can immediately see what's the projection for year 2045. Talking about the project list, this is important because this is where you can see a lot of value. Let's say we go on to a particular project, and we click on that, and we click on that project. Further, we can drill down and see what's the install year, risk, length of that pipe, and then the project name. And this is all customizable. If a utility says, hey, Bhavin, we don't want to see just the risk, we want to see the POF, COF, we can add those KPIs as well. And we can go to the project, and it will immediately reflect on the table, and we can drill further. And it basically, so we are working on a capability that would automatically zoom in into that particular project. So that's what we're working on currently, and it will, so that is really helpful. And the other module that we are working on is the planning, capital planning side of things. And I'm going to X this out. And as I mentioned earlier, let's say 2027, it's $1.13 million, $1.414 million. And that's, let's say for just our purposes, we want, that's too much, and we need to move the budget a bit. Maybe on the left, you can see the numbers will change automatically. So that's the analysis that I wanted to provide, that we have provided this capability, and you can click on any project, and you can drill down further about what's the length, how many assets, and we can go out and change the project here. And then if we say, okay, we want to change this, it will automatically calculate, okay, if the project cost will change, on how much will the project cost change, because material, and based on the rate data that we have based this. And further, we can drill into different types of projects, which was really important for the client, because they run a number of projects and they wanted to drill down and just select a certain project and drill down. And then the best part about when I was really amazed was there's an export functionality that we can export this data after making the changes. If you want to export onto an Excel file, we have enabled that particular functionality as well. Jayesh, do you have anything to add on this?
Yeah. So the one thing is I think you did talk about the user experience perspective, but when you're moving the project, those projects are being done on that particular year. So that may have impact on the risk calculation. So when you move the project, it allows you to dynamically calculate the risk for the associated assets, because now the work is planned to be done in that year, and it will be finished in that year. So how that is going to affect the underlying risk. So those calculations are done, and based on that, all other projects are prioritized, because it's not like things are not independent of each other. They are like mostly closely related, and cluster of projects may move, and one project activity may depend on other projects status too. So all these interdependencies taken care of, and based on that, the budget is optimized for the next possible projects. I think that's the goal. And we are also thinking about, like, when we are moving these projects, how we can take other activity that is happening in a city, so that if someone is digging the road, we can basically merge those work together and optimize the resource allocations accordingly.
So talking about how a digital technology we have envisioned should be, it should be customizable so that more modules can be added. Things change as we progress through the time. There's going to be more, there are going to be different issues that the utility will be facing. Just recently, there was this rule on PFAS, and I understand it may not be relevant to some of you, but it may be relevant to several of you. So we need, imagine if there was a module on PFAS in the linear system somehow. I'm not a PFAS expert, but if you wanted to add that, it needs the module. The DSS system needs to be customizable. That was a key that we focused on. It needs to be modular so that we can add more modules. Like I mentioned, the Resiliency is the one that we are working on right now. We vision also that if there's less of licensing cost, it would enable stronger digital adaptation. Licensing costs can be quite an issue for several utilities. And then talking about the data security, and if the data is maintained on premise within the utility's infrastructure, and however the utility deems its SOP is, then that's the most secure that it can get. So according to the utility, so the idea is that the DSS work on data that is on premise, and the data should be owned by the utility or the client, I mean. So that was really important for us, because nobody likes sharing their data, although we all do that. We all have been guilty of using Facebook, Twitter, and all that, but this just a side joke. And adaptable and scalable to any size of network, that's also key, because we all have seen the growth in the service area for several utilities, and we want to make sure that whatever the DSS needs to be adaptable to the scale. And the idea is to keep the cost of this based on the services required. It should not just be one cost and this is the base cost. No, it depends on the service and the size of the network, because it needs to be customized. The idea is to use the client, the utilities data, aided with general knowledge of the domain, and also similarly, we wanted the cost to be based on services required. Jayesh, would you like to add?
Yeah, no, a lot of things you have covered. I just want to make sure that we keep one thing in mind, and like digital technologies are basically allowing us to do things in a large scale. So we can process the data in a large volume and create it one time and use it multiple times across. So the scalability is an important, and the way the things are moving in, like we are adding a lot more infrastructure to existing network. So I think every time when we add new infrastructure or new network, we don't want the existing system to fail. So building that in a way so that you can do in a large scale is key for that.
Thank you, Jayesh. And I would be regurgitating the benefits of bringing data analytics. Your data could be in any form. It could be in a Word document, it could be written, it could be pictures, it could also be table format, like your SCADA output, or your process control sheets, or your lab operator books. All of that data is data. And there's been increased data collection. So the idea is to put that to good use. The current new workforce that coming in, they are more digitally savvy. Most of the young folks, they use smartphones. So we want to use that. And nobody says, I don't want to see my readings and see how am I consuming. I don't want to pay bill online. At least I don't. No. So this digital data analytics can enhance customer experience, as I mentioned, even in the equity side of things. It promotes intelligent asset management. As I mentioned earlier, it improves water quality earlier. For example, if DBPs are forming somewhere, or maybe there's a discharge, we can, data analytics can assist that by using your current data sets. And it's all about optimization, as Jayesh has mentioned a few times. It's all about optimization and delivering value, increasing the value of the assets, improving the operation and maintenance responsiveness, and assisting you in your endeavors. It was a pleasure presenting. I know an hour just almost runs by. We only have less than 4 minutes left now, so time for Q&A. Bob, I'll let you lead the way.
Yeah. So, we have some pretty limited time here for the Q&A. I wanted to kick it off with a question. If you have a question for either of our presenters today, please use the question and answer feature. You can ask a question in there. We will get it to them. Even if we don't answer it live today, we will be sharing that with our presenters so that they can answer those offline as well. But I think my question right now, I mean, this is a lot of information. It sounds like there's a lot of different avenues that you're talking about with this with this technology that could be really useful. It sounds to me like the lead and copper rule is like a big key feature right now, as well as that condition assessment. You mentioned that resiliency is kind of something you're working on right now. Is that like the next in line thing? Like where do you see this going? Like where have you heard your clients or your utilities who are using this currently? What are their interests with this as well? Is that resiliency piece like the next critical step for them? And then what would happen after that? Where are they finding interest in this?
So resiliency is becoming more and more important. It's not only because it's in the best interest of utilities to maintain the levels of service that they have, like impact of climate change, impact of being on the coastal area, impact of corrosion, impact of construction that's going on. There are different kinds of resiliency, but what we have been seeing is not only from the funding agencies and also the stakeholders, but also from, if the municipality has released bonds, then the bondholders too, the big bondholders too, they are mandating having resiliency in place. Now, it involves, as I mentioned, there are different areas that we answer, not only in terms of climate change and coastal, but it's also resiliency also feeds into the revenue collection as well, and that's one of the key areas, because the rate increases have not been as much, in my humble opinion and my little experience, they have not been as much to meet the future needs. So maintaining that balance of levels of service and the rate charge is also kind of building that resiliency up in order to address that.
Yeah, we did have a question that came in here about the advantages of ML, specifically on treatment plant operations. So it says, what are the advantages of using machine learning on treatment plant operation, given that concentration ratios and microbial processes are well described in literature? So what are the advantages then in the treatment process is their question.
Yeah, so when we are looking at a treatment plant, I was in a wastewater treatment plant for a long time. The idea is, see, the treatment capacity, depending on how you clean and how much do you clean, the treatment capacity may also go down. The efficiency of your blowers may go down. The chemical costs have been rising. So how do you maintain a balance between all of that and also maintaining your Well, I'm guilty. So I use the New York State terms quite a bit. I'm sure many of you all use it. The SPD's compliance. So how do you maintain that pollution discharge elimination systems compliance? So in all these places of uncertainty. Secondly, there might be an illegal discharge. There might be other places of process upsets. And maybe if you have an area where you're kicking down a tank and you want to make sure that you want to project new loads, what are the loads coming in with times change and as the flows changed, the SSOs, CSOs. So you want to predict what flows comes in. That's where also AIML comes into play. So I mentioned a lot of things, but I would love to get in touch with the person who has this question so that we can answer in better detail.
Yeah, I think there's a lot of things there that are really good. The resource optimization, energy optimization being very key critical components of how ML can help you. But unfortunately, we are out of time. We're actually butting up into the next into some future sessions. So I want to get through this quickly. Thank you to both of our presenters and for all of those questions that we didn't have time to answer. We'll get with you offline. Just a reminder that at the conclusion of this particular webinar, you will receive an email with a link to download your certificate to use for Stormwater University credit or for one professional or personal development hour for attending the webinar today. That concludes today's presentation. I'd like to thank Jayesh and Bhavin for their time with us today. Don't miss our next session addressing emerging contaminants in the water industry. You can join the session by exiting out of this event and going back into the agenda. Select the session by clicking on View Session button and then click Addressing Emerging Contaminants in the Water Industry session. So once more to our presenters, thank you so much, and we will see you in the next session.
Thank you.
Thank you.